Good morning, everyone. Thank you so much for coming to this talk on test-driven development with Python. My name is Prasiddha Vista, Pras for short, and I'm a senior site reliability at Versant, engineer at Versant. Today's agenda, we'll talk about testing. There's different terms when we think about testing. There's different words that we use in the industry, and we want to break that down. So what exactly does it mean by different types of testing? We'll then look into what test-driven development means. We'll then see the workflow that we need to follow when we are implementing test-driven development. We'll then see why test-driven development helps, why is it important, and what kind of benefits it can bring to a team or to an organization. And then we'll see different unit testing frameworks in Python. But at the end of this, we'll actually, the theory bit, the slides bit is a little bit less, because primarily we want to be focusing on demo today. So we'll go through a practical demonstration of how to implement test-driven development in using unit tests and also using PyTest. So we'll do two different demos as well at the end. So what does it mean by testing? Does anyone want to volunteer to take this question and maybe share what it means when you say testing? I ask this because there's different terms that we use in the industry. You know, there's unit tests, integration tests, stuff like that. So what exactly does testing mean? When you think about testing, what does it mean for you, for your team or your organization?
Just in a broad level, I think testing means before you're gonna push something to production or apply something, you wanna test or know a bit how it's gonna be implemented or how it's gonna react. I think that's what testing is.
Yeah, that's a good way to put it. You want to be able to make sure that whatever you're pushing to production works as expected and doesn't do anything unexpected, which can cause a lot of problems. Yeah. But what I would really want to share with you guys is there's all those terminologies, and we can talk about these. And we'll see at least the unit test part of it today in the practical demonstration. So there's different words that you use in the industry, like unit tests, which basically means testing each line of your code or your methods or your functions. So you're basically testing each line of your code and making sure that when you call that line of code, that you get an expected output, or it does what you expect it to do. So every line of code, your functions, your methods, you test all of that. When you think about integration testing, you're testing different systems. For example, if you have a function or a little bit of code that interacts with a database, so you're testing the integration between your code and your database. That's an example of integration tests. There's also end-to-end tests, where you're using tools like Cypress or Selenium in the front-end space, which allows you to test your application end-to-end. For example, the framework itself can log into your website, can do things like, upload a picture, for example, do the actual functions in your application, and then make sure that all of that is as expected. So end-to-end, the front end, back end, everything is involved in that testing. And that's what it means when you by end-to-end testing. So you're testing all the parts of your platform, and that's all automated for you. Now, there's also terms like system tests, where you think about functional tests and non-functional tests. So functional tests are tests that you perform based on customer requirements. So what is the application required to do to function? For example, a user will have to log into your website. That's a functional requirement because they need to be able to log in. So it's a must-have, right? For example, if for an application like Instagram, the user then needs to be able to upload a picture to Instagram. So that's a functional requirement. And when you think about functional requirements, unit tests, integration tests, these fall into functional requirements, which help you test those functional requirements according to customer specifications. So what does a customer what is he able to do in your platform functionally, like logging in, uploading, downloading, things like that, which are core functional requirements. And when you think about non-functional requirements, these are things like reliability, performance, security, and others. And the way you test them is using tools like regression testing, reliability testing, performance testing. So these are not like a must-haves, but these help improve, performance, reliability, and others for your application. And that's why they're non-functional requirements. So a user needs to be able to log in, but you might not care that initially you might not care that your infrastructure is scalable, for example, because without, like, if your users can't log in, that's your users won't be able to use your application or your platform. But if they're able to use it, then scalability, performance, reliability is your secondary requirement, and that's why they're non-functional, if that makes sense. And there's also acceptance testing, where you get end users or our customers to test, let's say, a beta version of your application. And then you get some feedback, and then you make some improvements, and then you release your feature. So being able to give a beta sort of release of your application for your end users or your customers to test to get some feedback. So as you can see, there's so many types of tests that you can implement in your software application or your software application lifecycle. And it depends on your business, on your team, on your requirements, on what suits you the best. In real life scenario, you usually see a few of these implemented together. So for example, you generally have unit tests for your code. You also have a bit of unit integration tests or even end-to-end tests to test the whole flow of your application. And generally, end-to-end tests or integration tests are harder to build than unit tests, because when you're talking about integration tests, you're talking about different systems, and you're actually thinking, like, when you implement this test, you're actually doing those things on real time. For example, if a user has to log in, you're actually building automation that goes off and logs into your website and verifies that the process is working. So when you think about like the whole end-to-end scenario, it's a little bit, you have to make sure that it's up to specification. So it's hard to build because, yeah, it takes a lot to integrate all the systems, and you have to know at each point what you expect, like the contract between systems and what the end result is, to be able to build an end-to-end sort of testing system. And on my daily life, so far I've seen unit tests, integration tests, and end-to-end tests being implemented, and they're really powerful. They save you a lot of time, and they expose a lot of issues with your code before it reaches production. Now, let's talk about test-driven development. So what does it mean when you say test-driven development? It's a software development process that makes you think about your requirements, the processes, and anything that the process or the application needs upfront. So even before you start writing your first line of code for your application, you have to be thinking about all the requirements, all the functionality of that code that you're trying to write. And we'll see this in an example in a bit on what I'm trying to say here. But for now, you can either do feature-driven development, where you're writing your code first, and then you're writing your tests. But you can also do test-driven development, where you're actually doing that inverse. You're writing your tests first, you're making sure that they fail, and then you're implementing the code for that test that fails. So, and the reason to do that is this forces you as a developer to front load all the thinking about your application up front. So you're not going in and writing your code and then thinking, oh, is this going to work or not? You're actually listing out all your requirements. Okay, this function or this method is going to have to do this, this, this. It's going to have to catch these exceptions. It's going to have to do these retries up front before you even write any single line of code, right? So that is why it's really, really powerful, because it helps you do all of these things, helps you think about requirements up front, helps you capture edge cases. Because generally when you do feature-driven development, you just want to build the stuff out. You just want to push it to production. You don't really think about all the edge cases, and then you miss a few edge cases because of that. But then when you're doing TDD, because you're forced to think about all those things up front, it saves you a lot of time in the long run, saves you from bugs and other defects in the code as well. And I think the main point is also that it helps you break down larger problems into smaller, manageable tasks or methods or functions. And we'll see this in a practical example in a bit, because this is also like really important. Because when you do feature-driven development, you might not care about breaking down your functions or your code into smaller pieces until you get to the test. And it's already too late because you've already implemented a bunch of code, which I'll show you in an example in a bit. And that's bad because if you have a bunch of code that does a lot, it's very hard for you to test that code and isolate that and test it that way. And I'll show you an example and it'll make sense in a bit. So yeah, on a high level, it forces developers to think about your requirements upfront before you implement any single line of code. So what is the test-driven development workflow? When you think of so first you build your requirements upfront, you take care of what you need to do in your function. Then you start writing a failing test first. So you write a test, and that should fail because you haven't really implemented the actual code, right? Then what you do is you go in and you actually implement the code that conforms to that test that you've just written. Once that passes, you go back and you refactor that code to make it better or to make it efficient or performant. So, and you follow this process all over again for every single line of code or the function that you write. And we'll see this in practice in a little bit. So you write a failing test, you make sure that it passes. You only write in just enough test, which makes that little test pass, and no more code, just a little bit that makes that test pass. And then you go back, write another failing test, write a bit more code, go back, and you follow that red-green refactor process again and again. The whole way. So you don't do feature-driven development here. You follow this process the whole way for all code that you write for your software. So you might ask, why test-driven development? We obviously talk about how it helps you think about requirements upfront, but there's also things like it helps you reduce the number of bugs. For instance, when you're testing when you have unit tests for your application, for example, you give it a lot of edge cases. You test it with a lot of inputs, different variables, different data types, for example, and you make sure that you cover all those edge cases. And what that does is you're more confident then to push that code to production because you've tested that piece of code with a lot of test cases, and you're comfortable. You're more inclined to then be comfortable pushing that code to production, right? Because you've got all the edge cases covered. You can also optimize performance because what you can do in your testing is you can give it large inputs, very large inputs. You can give it very small inputs, and you can make sure that the test performs, the code performs as expected. This improves code quality on a long run, I would say, because once you have tests and coverage in all your repositories and your developers and your team follow that pattern, that ensures good code quality over the long run because you're writing good code from the start. You're forcing everyone to write good code using TDD. And so it creates this culture almost where you build a certain standard over a period of time. And that is because you're following this process where you're offloading, you're checking everything up front, you have tests everywhere, and you're making sure that code that you ship to production it does what it says it's supposed to do, and it's also performant, reliable, and it's qualitative. The other one is test serves as documentation, and you might have seen these examples when you write tests as well, because what we do when we write tests is we give it an input and we sometimes expect an output. What we're effectively doing there is you're building documentation as you go, because let's say if, as a developer, I come in, I don't know what a function does. What I can do is quickly look at the test and be like, okay, it looks like this function takes an input, a dictionary, has two keys, and outputs this dictionary, which is transformed, and outputs a new key, for example. So just by looking at that test, I can tell what the input of this function is going to look like and what the output is going to be like once it performs the calculation and returns the output to me, right? So it also serves as documentation. And there's obviously increased confidence because the more you write code, the more you capture your requirements up front, the more you capture all the edge cases and you test your code with all the edge cases, obviously that builds more confidence in not just you, but the whole team to then continuously push code to production. And I feel like it also increases velocity, right? Because everyone's just pushing their code, everyone's more comfortable doing this over and over again. So I think it's more also about the culture than just one developer or two developers doing a TDD, implementing TDD and making it better. I feel like it's more about a culture thing where if you implement this throughout your code base, everyone follows the pattern. And that's where you see the real power of TDD. But I should also say that you don't have to do TDD. It's not a requirement. Some people don't like TDD. Some people prefer TDD. Some people just prefer doing feature-driven development, where they just want to write code and then do the test after. And that's completely fine as well. So like no one forces you in the industry, or no one's going to tell you, hey, like you have to do TDD 100%. Maybe some companies do, but I haven't heard of such companies. And especially where I've worked, we've always been told that just do what's best for you. So it might work for you, it might not work for you. It just depends on the current situation you're in and the team and the tech stack and other things as well. So is it feasible? Do you have time? Do you not have time? Things like that, right? So yeah, it might be for you, it might not be for you as well. And I wanted to put in some facts here as well. So according to a case study from Microsoft and IBM a while back, they researched TDD between teams who performed TDD and those teams who did not, or they performed feature-driven development. What happened there was they found that there was a 60 to 90% decrease in defects compared to non-TDD teams, the teams that didn't implement test-driven development, right? So that shows you that this is a big number, 60 to 90% decrease in defects or bugs that's been pushed to production. The teams also experienced 15 to 35% increase in project completion time, right? That is negative. What happened here is, so that once they implemented TDD, they saw a decrease in defects, but they also saw an increase in time taken for them to push their code to production. And this is because it takes time. It takes time to implement tests. And that's what I was saying before. It might not be for you because you might not have time to implement it. So although they found that there was 15 to 35% increase in the time taken, they also agreed that the additional time was offset by the reduced maintenance cost in the long run. So what does that mean? So they said that, okay, sure, like there's 15 to 35% increase in time taken to finish the project, but on a long run, they found that this time is going to be offset because they won't have to do a lot of maintenance on their code in production. They will have less tech debt. They will have more, because they will have pushed good code from the start to production, they won't have to do a lot of maintenance on that code later. Versus if they just had done feature-driven development, or they didn't focus a lot on testing, and you accumulate all that tech debt over the years, and it's really, really hard then or it takes a lot more maintenance and manpower and resources to then go ahead and like fix that tech debt or make it better, if that makes sense. So yeah, this was a really cool data that I found on the internet that I wanted to share with you, that like it really does help. And there actually isn't a lot of studies. I wanted to find recent studies on this as well, but I couldn't find any. If you guys have any, find any examples or research data, let me know as well. But yeah, I think we need more research in this area as well, as I wasn't able to find a lot of research data. This is a good one. TDD helps with, but does not guarantee, good design and good code. Skill, talent, and expertise remain necessary. From Esko Luontola. So what does that mean? It sure helps. I'll show you a few edge cases where even though you've written a test, even though it says 100% coverage, where you've covered all the lines, that might not be true, right? And I've seen a lot of those cases where tests generally don't do anything, like unit tests. And then you're like, oh, what is it really doing? What's the benefit, right? So sometimes people just write the tests, right? And the test really isn't doing anything. So I guess what this is trying to say is that you still need to be able to know what you're testing, how you're going to test it, how you're going to come up with those requirements up front, right? So you need that experience. You need to have that experience to have built software, to be able to think about all these requirements up front, all the edge cases up front. So it's not a 1 day or a 1 week thing to learn and do. It takes a while, but then once you get a hang of it, I think it's really valuable. But yeah, you need to have that skill. You need to know what you're doing as well. And I guess what I'm also saying is you need to be careful of those scenarios where, okay, you have 100% test coverage, but it's not really 100%, because once you start looking into the tests, you're like, man, what's going on here, right? It's not really testing a lot. It's just like saying, hey, I call this input equals output, which is the same dictionary, for example. I'm like, so what are you testing? Like, you're testing A equals B and they're the same objects? Man, that doesn't make a lot of sense, right? So yeah, you have to be sort of, careful as well in terms of what you're doing with your tests. And we'll see an example of this. I've got a practical example that I can share with you guys today. And the final slide. So we'll be looking at a few demo examples in Python today. But before that, I just want to quickly show you that there are a few frameworks that you can use to implement TDD in Python. The first one is Python's inbuilt module called unit test, which you don't have to install when you have Python installed. It comes with Python. But with unit tests, you have to install nose, which is a test runner. So all it does is it runs the test that you've written. Nothing fancy here, but these two things go side by side, they're hand in hand. And then you have PyTest, which is sort of a modern framework, which came in recently, which you have to install. And you use PyTest to then implement your tests, which we'll look at as well. So we'll look at these two today. And there's also a behavioral, it's called BDD. So it's not test-driven development, it's behavior-driven development, where I think if you've worked in front end, I think this is just where you can say each line, it must do this, and then you write some tests. It must do that. So basically implementing tests in natural language. And as you can see, we have behave installed, check whatever. We implement this test. So each of these, given, when, then, it allows you to write a natural language and then test your code that way. So this makes it a little bit intuitive or interactive and easier to, and I've sort of not implemented this so far, but I just thought that this is interesting where it can, and I see a lot of this implemented in the front-end space using Jest and other frameworks like Cypress as well, where it uses behavioral-driven development, I think, where you can write your tests in natural language, which is pretty cool. So that's behavioral. That's another framework for testing your code, which looks like this. Yeah. Any questions on the slides? And you can scan the QR code to add me on LinkedIn if you haven't already, but I think most of you have. Any questions from the slides before we go into the demo?
Quick question. With the testing, do you rely on any third-party products or services, or do you just rely on the modules?
You generally have to install tools that, so for example, unit tests comes with Python, but generally I see a lot of programs or a lot of projects also implement PyTest, which is a modern framework, which is like new, and it's got more tools, helps you write tests a little bit intuitively. So I feel, so these things you have to install. You have to install packages, and even for unit tests, if you want coverage, for example, you have to install the coverage package. So yeah, you generally have to install packages no matter what you use, I think, in order to get those extra functionality. For example, you're not just testing, you also generate HTML files, for example, of your tests, or like an XML file that you can put in a GitHub repo saying this is the coverage for this repo, like 100% or 90%, for example. Yeah, so you have unit tests inbuilt into Python, so you don't have to install it. It comes directly, but even to run that, you need to install nose. So as you can see, you have to install a package already. Yeah, you generally have to install extra packages to get desired way of testing things. Yeah. Does that answer your question?
Yeah, it does. Thank you.
Yeah. Thank you. Any other questions? No? Okay. Obviously, you can ask me more questions later as well. We'll move into the demo now. So first of all, so obviously we have two demos today. We'll first use Python's unit test inbuilt module, but we'll have to install nose, these two packages. And then we'll test, we'll have our first test scenarios, we'll implement TDD, and then we'll go into Poetry, using Poetry to install your virtual environment. So in this case, we're using pipenv to manage Python virtual environments. And I also wanted to show you Poetry, which is the newer tool that we use to manage your Python virtual environments. And we'll also use PyTest for this. So I just wanted to show you a variety of tools, a variety of ways, different ways to implement TDD as well, and also the tooling around Python at the same time. And feel free to stop me if you have any questions midway as well. So what we'll do first is I've got a repo here. I don't have anything here except for this README and a makefile. I use makefile to run all my bash commands. So all I'm doing using makefile is, for example, as you can see, I'm running some commands like pipenv install these packages, show me a graph of what's installed, and I'm running tests with these commands. Right, so that's all I'm doing. If I go back to my README, we'll just follow the README. So in order to follow this, we need to have prerequisites installed, obviously Python 3, and also pipenv for managing the virtual environments. So I built a simple makefile command to check my prerequisites. So to see the versions of Python and pipenv before we start off. Actually, sorry. Then as you can see, I'm using Python 3.9, and for pipenv, I'm using 2023 version. And that's all good. I'm happy with that. What I'll do now is I'll use pipenv to install my packages. And in this case, what I'm installing is, as we know, unit test is inbuilt, so I don't have to install that. But I do have to install nose2 and nose2 coverage, because nose2 is used for running the actual test, which we'll see in a bit, which you can see from this command as well, run nose2. So it's nose2 is actually what's running the test. And then coverage is for us to be able to generate the coverage in XML or HTML to then export that, put it in our GitHub, for example, or different CI/CD tools and others that use that XML. And we'll see, we'll generate a report in HTML to look at that. What we'll do now is we'll go ahead and install those packages. Right, and as you can see, it generated I'll show you what it generated as well. Actually, what I'll do is I'll clean this environment and I'll show you. As you can see, there's nothing on the left. Right, I'll clean this up. So when I install it, it's going to do two things. So it's going to install these packages, but because it's using pipenv, it's going to create a new pip file and also pipfile.lock, which basically means that for this project or this environment, I'm going to be using those packages, which is nose and nose2 coverage. And then this is in the development namespace. So you can install development packages or just packages. So the difference is development packages is like things like testing, linting, formatting, things like that, which you use locally or in your CI tools, but you don't have those dependencies in your production environment. So that's why you can separate them. That's why you have dev here, and you look at this in a second, right? So when I say install packages, you'll see on the left, it generated a pip file and it also generated a pipfile.lock, right? And what you can see here is a graph of what it's installed. It gives you, it's installed Berta 3. Oh, why did it install Berta 3? Yeah, maybe it's a dependency of nose2 coverage. That's what I want. So I think what's happening here is, okay, so what I can do is then go into pipenv shell. So I've installed this pipenv environment, but I can go inside the shell and I can do a graph. Yeah, this is not going to work. So this is something to do with my virtual environment, which is out of scope for this. So I'm not going to talk into that. Basically, something weird is happening where I'm trying to use 3.9. It's using 3.11. But this is not going to stop us from testing this, or for this demo, so I'll exclude that from this. So if I go back to the README, I've installed these packages, and I can verify those because I can see them in the pip file. And as you can see, these are dev packages, not packages. So if I've installed anything as a package, it'll be listed here. And those are the packages that you want in production, right? So these are development ones. And then what I can do is, now we need to remember the rules of test-driven development. So we first write a test that fails. Then we write the test supporting functionality, the code that works. And then we go back and refactor if we have to make it better. And then we follow the same process again and again, right? So that's the whole process of TDD, and we'll follow that. And to make it simple, what we'll do is we'll work with a simple calculator app, which just has one function called add. We'll just do simple addition will give us, and we'll have different edge cases or test cases to then implement TDD. Now, as we said before you start your TDD process, what you do is you come up with all your requirements first, right? So what is your application supposed to do? Or what is your function, in this case, add function? What does it need to do? Even before you write your code. So I'm like, I thought about all these requirements. So the calculator should have an add function that takes 2 arguments because it's adding, because you can add, 2, 3, 4, 5 numbers as well. But for this application, for this function, I'm saying it only adds 2 numbers, right? But now I'm trying to tell you the difference, right? So because you're doing this, you're saying that the function only takes 2 arguments. But if you didn't think about this upfront and like you just build the function, for example, and the function could take multiple arguments. It could take 10. You could take like million arguments if you wanted to, right? I don't know if that's a limit, but what I'm saying is you're hard defining the requirements. You're saying exactly 2, right? So that's what I'm trying to say here. And he's saying that the function should return an integer because there's float numbers, there's decimals and others, but you want to make sure that it returns a number. An integer, sorry, and the add function should validate that the arguments and return erase a value error. For example, if they're not numbers, right? So if you're trying to add a number and a string that's not compatible, you'll raise a value error. So you catch that, you raise it. So that's simple, right? Fairly simple. But what I've done is I've front loaded all the requirements of what this function is supposed to do up front. So I don't have any piece of code right now. As you can see on the left, there's no folders, there's no Python file, but I've come up with these requirements. So I exactly know what I need to build. So I'm not thinking anymore. So once I go into the test and I start implementing this, I'm not thinking anymore. What I'm doing is I'm using the tool to implement this thing, right? Because I've offloaded or front-loaded all my thinking up front. So that's really important when you think about TDD. This is the actual value that you get from doing TDD is you're offloading everything or front-loading everything up front. Now, at this point, then you finally go in and you start developing or you start writing a first test that fails, right? Now I want to be able to, so what it says is, if you want to test calculator module, which doesn't exist, what I'll do is I'll create this file first. And what I'll do is I'll create, generally this is the folder structure. You have a test folder. Create a test calculator.py. I'm here, I'll put it here. Then what I'll do is what it says, write a test that fails, right? I'll obviously push this to GitHub for everyone else to see later. But what it's saying is, if you want to test the add function, you write a test add with some arguments and assert that the result is what you expect. But this is the red step because the add function is not implemented. And when we run the test, it's going to fail. So let's see if that's what it does. What I'll do is, I'll write it down so it's intuitive. So we haven't implemented the code. So it's going to be in the source folder. That's the nomenclature of the folder. So we didn't have this yet, right? So calculator, import, and we haven't written the actual code yet. But what we're saying is, so we'll now test the add function, right? So what we're saying is when we call add function, let's say, like, I don't know, 5, 3, we expect that to return an integer, right? We expect the result to be 8. So when you're testing, what you can do is basically use asserts. So you can say assert this result, which is the result when you call this function called add, is going to be 8. So this is what I expect to return. And we can put a simple print statement here to look at the result before it prints it out, right? So one more time, what I'm doing here is we haven't implemented this module yet. That's why it's saying it doesn't exist, could not be resolved. So it's saying when we implement this function, what we expect that function to return is 8 because that function takes 2 arguments, which is here, and it returns the sum of 2 arguments, right? So this is the first test case we're testing. But now let's go and run it. And what I mean by run it is if I look at the make file, do you have questions? When I look at the make file, what I'm doing is I'm running make test. When I run make test, it runs nose2, which is the test runner that we installed before. And then it gives us a verbose output, and it finds the test in this test folder, right? So that's all it's doing. When I run make test, there you go. It fails because there's no module called source, right? Because we haven't implemented it at all. So what we'll do now is we'll go and implement the code, right? This is the red step. So red, green refactor. We've done the red step. We'll now do the green step where we'll actually implement the code, and then we'll try and refactor it if the code can be improved. Okay, not inside tests. So I'll create a source folder. This should still fail because although it finds the module, as you can see, there's no add function now, right? So what we do is we go here, we create a function called add. I guess we'll follow the README. Then it tells us to, now this will fail, which failed. Then we implement the test supporting functionality. And this is the green step, right? So we say the function add, which takes 2 arguments, which returns an integer, should simply do return a plus b, right? That's all it's doing. Then when we run make test now, what do you think will happen? I think it will pass, because if we look at the test file, if you look at the test and the test file, so result, it's calling this add function. As you can see, you can resolve it now, and I can look at it. When I highlight it, it's saying, okay, it's a function that takes 2 arguments and returns an integer. And then I'm calling that function here, and I'm asserting that the result is 8 because that's what I expect, right? Then I run it. Okay, still can't find it. I think I haven't saved it. Okay, yeah. So this is the classical issue where I didn't save the file, which I have saved now. And as you can see, what happens is it tested this file. It tells me that it ran one test, which is test calculator.test add, this guy. And it's telling me the result is 8 because we put a print statement here, right? This is what we expect. So we've actually implemented the first test. In this case, now we've done the red step and the green step. Now we do the refactor. But do we need to refactor it? It's a simple function that doesn't do a lot. So I don't think we need to refactor this function. So we'll move on. What's the next step? Right? So this will pass, which passed, and we saw that the result was 8. Now, okay, we can improve the function actually. Yeah. So there's a way that we can now refactor the function, right? So red, green, refactor. What we did was we failed the test first. We then implemented the code, which was the green step. But now we can actually make it better, which is the refactor portion. What we can do here is we can use Python's inbuilt sum module to perform the calculation, right? I mean, this is also fine. It's not really like huge difference, but I'm just trying to show you that you can, the refactor bit, which is then you're trying to make it better, right? So what we'll do here is simply replace this with, sum, and actually sum, what you'll see is it takes an iterable, and that's why you see a list here. So why is this bracket here versus before? It's because if you look at the sum function's definition, it takes an iterable. And you can give it a start, which is an integer, but we're not doing that. So you can give it, hey, start from number 1 index, for example, but you don't want to do that in this case. All right, so for this, what we've done basically now is we've done the refactor portion. We've made it one step better by using the inbuilt sums function versus, doing return a plus b, right? I mean, yeah, so that's the only difference here. But hopefully then we see the same result. There you go, same result, test passed, but we've done the refactor bit. All right, so we then move on to our second requirement of the test that we've listed here, or the third, which is we validate that the arguments, and we see that both are numbers. If they're not, we then raise a value error. Right. So for that, we need to use those 2 tools. Oh, I'm so sorry. Where did it go? Oh, sorry. So because we installed Nose2, we can use a helper from that tool, right? So it's got a helper module that we can use. So what we're saying is we're saying test add raise value error if non-integers, not int. Right, I want to write it. I'll just write it down. Helper. So you can use the helper to say things like assert is equal, assert not equal, assert raises, assert not raises, assert true, assert false. So you have all these functions that you can assert to test your functionality. Obviously, it's all sort of in the docs. But yeah, it's a helper function that you can use to assert things. You're basically saying is A equals B, for instance, right? Is A, which is an array example, equal to B, which is also an array, like all those kinds of things. You can do a comparison, right? And that's why we're using the helper tool. So you can say helper.assert raises, value error, which we haven't implemented yet. This is TDD. Remember, we're writing the test first. We're saying when we call add, let's say, this is a string, but I'll give it a number. So what I've done effectively, this function takes both. Oh, okay, I haven't defined. Oh, sorry, I'm actually writing test in a in the actual module. So I'll write it here. So I'll import this on this side on the test file. So basically, I'm saying, as you can see, the function's still here. We haven't implemented the value error. We haven't effectively implemented checking that are both of them string or like both of them integers. We haven't implemented that, right? So this should fail. Right, so let me save the file, save that, and then run this test, see if that fails. What happened? So maybe instance stir. Yeah, okay, I see what's happening. So it's failing for this test. Yeah, when it's calling it, but it's failing because it's saying, hey, like it's giving you a type error, which is saying you can't add an integer and a string, which is correct. But what we want to do is catch that and not let the function fail or not let a program crash, but catch it and then raise it ourselves, right? So what I'm saying is now we'll implement the test for this. So we'll actually validate that both of those arguments are integers, right? So then we'll go back here and we'll implement this. So basically the same version of this function. I think at the same time, I'll just copy paste, but I'll explain. So what I'm saying effectively here is before you only had this line, right? So you're basically summing the two arguments, returning the sum of two arguments. But now what I've got is a check, right? So I'll remove this first. Just if you look at just that, what it's saying is if you just see this, you're saying if A is an integer, then raise. Well, you don't want to do that. So what he's saying is if not. So if A is not an integer, you raise a value error, right? So that's what it's saying. And then I've also got an OR logic here. So if A or B is not an integer, then you raise a value error, saying those arguments should be integers, right? So I've effectively put in that check. So we did the red step. This is the green step, where we now, if we run the test, it's going to pass. Because if you look at the test, you're asserting that the function add raises a value error if you pass it non-integers, which is what I'm doing here, and which you should hopefully pass, right? So as you can see, that also passed because this time you're saying it's effectively raised that error, right? So the way you can also confirm that the code has reached this raise section is, put a simple print. I mean, we've already seen the error, but yeah, arguments must be integers, received A and B, right? So what we can do now is run that test again. Arguments must be integers, received, string and a number, right? Put some print statement just so we can take a look at it. So what we've done here is effectively done the green portion where we've implemented the code that supports this functionality. So we're effectively validating all our arguments. Right, moving on. Feel free to stop me if you have any questions as well. We don't have to wait till the end. Yeah. As you can see, this will pass, which passed, right? So then, in this case, we don't have a refactor section because this is, I don't think there's a better way. Maybe there is, if you guys can think of it. But for now, this looks good to me, so I don't have to do the refactor portion. We've done the red, we've done the green, and that's good enough for me. So this is sort of a really basic example of using an add function to using TDD to implement the code, right? So we first implemented the test, then the code. With testing, what you can also do is you can generate coverage for your tests, where you can say, okay, I've covered all the lines of my code, or maybe a few of those lines have not been covered by a test. So it exposes all of that. And it also gives you an XML or a coverage file that you can expose to others. If it's an open source repo, you can put it in GitHub. And sometimes you probably noticed when you go to repos, you see like 100% coverage, like a green tag or badge there. That's how they do it. They generate a coverage file and they share it with public because it's an open source repo. And that's how you see that there's 100% coverage or 90% coverage, things like that. So we'll see that now, right? What we'll see here is in the make file. So I've got a make test file, which we've been running in the nose command to test it. But there's also a make test with coverage command. And this is where we need another package, right? So we need the coverage plugin for nose installed. Then we can say the same nose2 command, but this time we're adding, hey, run with coverage, but also give me a HTML file, right? That's what I'm doing. So when I run make test with coverage now, what you'll see is it's installing that new package up here, installing coverage too, and updated my pip-file.lock, and it ran the test. But this time what you'll also see is you'll see a html.conf file here, and you'll see this index.html. Open to the site. Oh, no. Open preview. So I can open it on VS Code. As you can see, statements 5, missing 0, 100% coverage. So basically 100% coverage on the code. I actually had oh, this is interesting. Okay. Because then I actually wanted to show you as well. Run test with coverage. Okay, what I wanted to show you was like missing and stuff here. So give me 1 second. Okay. Wait a second. Let's Google this. By nose2. And we can see the missing lines directly here, like missing, but I wanted to show it here. So there's like another command we probably need to add. I thought I had it here. So there's missing lines. Coverage config. So like something like this. Nose2. Okay. Coverage report. Term missing. Maybe it's maybe if I do that then. Yeah, okay, so there you go. That's coming up. So because I changed it to be a HTML, I just wanted to show you as well, because this is really helpful. So it says doesn't show you missing because there's no missing lines right now. So it's saying 100% of the code is being covered. But what I can do now is, for example, if I close this and then remove the test for, okay, there's this one test, but if I comment this out, as you can see, 20% is covered. There's 3 to 6 lines missing. So you haven't covered, 3 to 6. Yeah, even this is not covered, but I don't know why it says 20%. The whole thing's not covered, but you get the point where, it gives you missing lines that haven't been covered by the test. And this is also really useful because you can see, okay, I've tested these lines, but not these lines, right? So Now I want to show you a gotcha, which I talked about before in the slides as well, which is if we go back to the README, hopefully that makes sense. When you test it with coverage, so you're generating your coverage report, which you can then use it in your CI/CD pipeline or in your GitHub to do other stuff. You can expose that to your stakeholders and for compliance, for example, and other things. So there's a gotcha as well. For example, sometimes, and this is what I wanted to tell you before, was sometimes you have 100% coverage, but what you'll find is that the code's not really testing or not doing anything, and you want to be aware of those things, right? And I've just got one small example. There's different cases where you find those examples like in real life, but I want to make sure that you're aware that these things happen and not just trust this number here, because already you can tell, like, it's 20%. What do you mean 20%? The whole thing's not covered. You know what I mean? So yeah, so you don't always trust this, but you actually look at the code and you see what it's doing. And to test this, what we'll do is, we'll put this simple function here, or I'll just for this, I'll just add these two functions, and I'll add these two tests as well. I'll test this one first, for example, and then, okay, yeah. So what I'm doing is, if I look open to the right, so I've got two functions here, some other function that calls this function that adds those two arguments, but then this some other function returns the output of multiplication of those numbers, right? So very weird. But I wanted to show you this because, as you can see, so this function, when you call this function, it calls another function that does addition and returns the value, but we're not capturing that value. We're not doing anything with that. And then what we do actually is we return the multiplication value, like the multiplied value of those two arguments. So, and what I want to do now on this side, as you can see, is I've imported that function, some other function, this guy, and I'm saying, when I call this function with 1 and 2, the result's going to be 2, right? I mean, let's do better. It's going to be 6, right? So I'm going to run this test now, and tell me what's going to happen here. What will you see? Can anyone guess? I guess what I'm trying to see is, do you think, because I'm calling this function, I'm testing this, is this going to give me 100%? Because this function already calls this function? I mean, it'll make sense when I run it, but can anyone guess where I'm trying to get to? So I'm using this test function to call this function, but this function calls this other function, right? But I haven't got a test for this. I've only got a test for this, right? So now see what happens, right? So we'll say, okay, make test, don't run coverage, just run test. Helper assert equals. Assert equals, as you can see, the helper has a lot of asserts. So you can do assert in, assert is instance, assert is not, less, whatever. That's so many things that you can do, so many conditions that you can impose to build your test, right? For this case, I'm saying assert equals. When I call this function, I expect the result, this function, to be 6. That's what I'm saying, right? Yeah, but I want to show you the gotcha. So when I run it again, okay, it's saying whatever, this. Okay, I need to see the coverage. Yeah, okay. I need to run it with coverage. As you can see, what happened here? Can you guys guess, or can you understand this now? I mean, I'll explain it, but what this is telling me is that all my code is tested. But how come? Because with this function, in this whole module, I haven't got a test for this guy, have I? I have not. So what's happened? And you see a lot of this in real life and in production, right? And I'm like, man, what's happening here? And I'm gonna go, oh, you haven't even got a test for this. How come this is 100%? It's not 100%. It shouldn't be, right? But what's really happening is, can anyone guess? Or I'll just say it. All right. So I'll say it. So what's happening here is, because I'm calling this function and I'm testing it, it's already calling this function, right? So as far as the test is concerned, it's like, oh, cool. When I ran the test, all of these lines are covered, right? All the test runner cares about is lines of code. It doesn't go into the logic. It does not know what's happening. And that's why, expertise matters, experience matters, because, you can just write tests that does nothing, like this, or, you don't even test this guy, right? You can only test this guy and be like, oh, cool, 100%, I'm done. My job is done. But then the code actually is, there's a bit of a gap because you haven't tested this function, right? So all that's happening here is, when I call this function, it actually called this guy, right? And because it called this guy, it's like, oh, the test is like, oh, all of these lines have been called when I call these test cases. And as far as it's concerned, it's done. All right, hopefully that makes sense. If it doesn't, just reach out to me after the session, and then I'll be happy to go take you through all of these edge cases and gotchas again, unless you have a question now. Yeah, I thought this would be really valuable because I see a lot of this all the time in production. And this has been, yeah, like, that's why I'm like really looking to the code these days and not just saying, oh, 100%, right? Any questions? Otherwise, we'll move into, so this is, using unit tests and installing those, which is the test runner, and implementing TDD using those tools. Now we'll move into implementing TDD with a more real life example using PyTest and Poetry. Okay, yeah, because that's all I have here. Oh, okay, sorry. Actually, I actually missed a little bit, which is, so how can I make this better? So I know that this is not being tested, right? So what I really need to do, or what I really need to do in this test is actually change this. What I really should be doing is this guy. If I paste it, because we don't have a lot of time. So what I'm saying is something like this, where it shouldn't even, some other function. In Python, you can use patch. In unit tests, which is the inbuilt module, has a package called patch, which you can use to patch objects. So for example, what I'm saying is I'm importing this guy, source dot. So I don't need to import this anymore. I mean, I probably need to, but yeah. So what I'm saying is I'm patching this, so I'm mocking this away. So basically, when I call this function, what I'm saying is when I call the sum of the function, this function should be mocked away. So he's saying you don't want to make that call. You want to actually patch it. And when I do that, what I'm saying is, so make sure that the return value of this function is 2. And then you call the sum of the function, and then you test. So let's see what happens, right? Now what you see is there's a missing statement, which is number 9, which is this function, right? Because effectively what you did is, before you were actually calling, when you're calling this function, it was actually calling this as well. But now you've patched it. You're not actually making that call. You're actually patching it. And you're making sure that when you call this function, this doesn't get called. And because that didn't get called, your test is like, hey man, that line is not covered because that wasn't like really called. Like that when you run the test, that this line wasn't called, because that's as far as it's concerned. It's like, hey, did every line get called, right? And this line did get called because we patched it. We're like, hey, when you call this function, patch this other function, right? And in this point, we'll have to then implement a function for this. Oh, sorry, a test for this too, right? Because we haven't tested it. We won't do it now, but you get my point, right? And then you'll have to implement this test as well, like something like this, right? And then you go 80%. So what's missing? Line 12 and 13. Okay, you don't want, like, this is just imports. This shouldn't be the case. As you can see, I'm still saying 12, 13. Oh yeah, sorry, 12, 13 on this side. Interesting. But yeah, you get my point. We'll move on to the other tests, but hopefully that makes sense. You need to be able to like be careful on and see what exactly it's doing. Okay, so now this time we'll look into a more practical sort of example where we'll use a recognition, which is Amazon's sort of facial recognition, like text recognition sort of AI tool, to then implement this function, like this app, and then we'll obviously use TDD to build this app. But in this case, we won't use unit tests or PPEN. We'll use Poetry for managing our virtual environment. We'll use PyTest to run our tests and to generate our coverage file. And the general process is, again, the same. We'll write our requirements. We'll then go through the process of red, green refactor and see how that works. And for the purpose of this, we'll be creating a few functions called get image bytes. So for these applications, for Amazon applications where you need to interact with it, for example, in order to detect a celebrity, you need to provide it an image, right? You can either have the image in an S3 bucket in the cloud and pass it the URL, or you can have a picture locally, which I've got in this case, and then read the image, read the bytes from the image, and then pass it on to these functions to then get an output or a result from Amazon, right? So we'll be adding a get image function, get detect labels, which basically detects objects in the picture that we give it, detect celebrities, which will be able to detect any celebrities in the image, and then detect text. If there's any text in an image, it'll also be able to detect that. So we'll implement this app. Right, so first of all, we define requirements as any other, TDD. First thing we do is define requirements before we implement our test, before we implement our code. So in this case, the get image bytes should take an image file path locally, and it should return the bytes for the image, because that's what it's doing. It should be able to read and return the bytes. It should raise an exception if that image path is not valid. Detect labels. It should return a list of labels in the dict format, and it should raise these exceptions. This could be scenarios where if you have automation around something like this, you generally have a retry around it, where errors like this is coming from Amazon services, right? So Amazon service is down, raises an internal server error, which is 500 error. That's when you then go and catch those and you retry, for example. Detect text basically detects text in the image. We have similar sort of tests. We should return a list of text and then should catch these exceptions. Similar to this celebrities, it should recognize celebrities and return their names and information. And it should also catch these errors. So let's start it up. For this example, though, because it's going to be a lot, I've got our base files ready, but they don't have anything, right? They just got a class where I've got the Boto3 client. Boto3 is the package that we need to interact with Amazon, and that's the package that I've installed, and that's the client. So I'm interacting with that recognition client, and I've got my functions, which I haven't implemented, right? Because this is TDD, detect labels, detect text, whatever. What we'll do is we'll go implement those. So if I read the README, it says first, obviously, we implement the test. What we'll do is we'll do here, go to the side. Oh, sorry. Yeah. So these I've already got here. As you can see, I'm importing PyTest, the class, which is here, the code itself, and I'm initializing the class up here. And then I'm testing the first function, which is get image bytes. So according to our requirements, it should be able to read a valid image and then return bytes for that image, right? So we need to test that. So what I'm doing is I'm saying, when I call this get image bytes function from that recognition class, which is this function, what I should get is bytes. When I call it, the result should be bytes. And the bytes, there should be bytes. I mean, the result should contain data, and which is what I'm validating here, right? So if I then run, I mean, I should have checked. As you can see, I haven't installed anything, so I still need to do. With Poetry, you can have guided install, so I'll do that actually. Yeah, package name TDD Python. Yep, that's the version. I'm saying testing and development. Right. Yeah, that's me. MIT 3.9 define. Yes, so I need to install Boto3. So this is what I'm trying to show you, interactive way of installing your virtual environment with packages as well. What I'm saying is give me Boto3 environment as part of installation. The first one I select and the latest version. Yeah, that's all I want. And yeah, these are obviously development dependencies. This is my main dependency, the Boto3, because I'm interacting with recognition, which is an Amazon API. Add a package, leave blank. Yeah, development dependencies. Now I say yes. This is where I want to install PyTest. Right. Install latest. Oh, I didn't install the other bit, but so what I can do now is if I go, I'll actually clean this environment, do it again. I just wanted to show you how you can interactively initialize your Poetry environment. This doesn't create a pip file, it creates a pyproject.toml. And as you can see, it's got all my information that I put in there. It also tells you what Python I chose, what package I installed, what development package I installed, right? So then what I can also do is PyTest, because I need 2 more packages, PyTest cov, PyTest mock. I can also install it that way, and then I can say in the development group. Group. I can say, what's the command? So I've got like a automated version of this, as you can see here. Okay, it's a dev dependency. Oh, it's not PyTest install, it's Poetry install. Development group, 3.9. Local. Oh, that's very bizarre. Okay. Again, Python issues with my local. So what I'll do is I'll actually just run this command, which I've already got working, which does the same thing. You know, I've just automated it. That's why it's really handy when you automate these commands. As you can see, this time it just worked. And I don't have to deal with errors in a live call, which is amazing. So I've installed all my dependencies now. And then if I go back to the first test implementation, okay. Yeah, as you can see, this test should now fail. This is the red step where I'm saying, okay, I expect the function to return image bytes, which it doesn't do. So what does it do when we run make test? And this time make test is a little bit different as well, because we're using PyTest, right? If you remember, previously we used Nose2 to run the tests, which was the unit test framework. Now we're using PyTest, which is another framework to run the tests. Sort of similar. It's just a new version. It's got more features, and I feel like PyTest is what a lot of companies are adopting now, as well. Yeah. So we just run make test. As you can see, when it called, it's saying false is assert false. It's basically didn't get the expected result. It's not bytes. Is basically what it's saying. Assert false. Right. So it's expecting this to be true, but it's false. So that's why it's failing. And now we go and implement the code because there's no code for it. Right. So then it says it should fail. Yep, it's not implemented. Then I go ahead and I go here and I implement this. Take this away. I don't need it. What I'm saying effectively here is when I give it an image path, it's going to read that image as an image file and then return. So when it returns, when it calls this read function on that image file, it basically returns bytes. As you can see, the return value here is bytes. That's how you can tell. So, okay, now then hopefully it should pass. Right? So this is the green bit where we're saying, okay, it did return bytes. How can you verify? I think you can print. No, not len image bytes, but just image bytes. Let's see if this prints it. Oh, okay, it doesn't print it. It will print it if I make the test fail. And so now, as you can see, all this is the bytes. That's the bytes that it read, right? So just wanted to show you that. And yeah, so that's a green step. And I don't think we need to refactor this. I think it's good enough. But yeah, if you wanted to refactor it, make it better, then this would be the time, right? And then what we do then is we also implement the other check where we say when we give it a non-existent path, it should then fail, right? So this one's testing for valid image. This one's testing for non-existent image. For example, so this image actually exists if I show you. So there's images inside the source folder, and as you can see, the city.jpg actually exists in this first test. That's how he was able to get those bytes for the image. But this doesn't exist, right? So what do you think will happen when, so what I'm testing, this is the red bit, I don't have the function doesn't implement it, or it should, like, yeah, but as you can see, this doesn't exist, and when I call it, it should raise a file not found error, which it does. It does automatically, it raises it because it goes to open the file here, and it fails with an exception, which is the file not found error, which is what I'm catching here. This should actually just pass, as you can see, right? Because it raised. But what you can do is assert not raises. Not raises. I don't know if it's not raises. Maybe not. Yeah, it does not have to. There's something not assert raises. PyTest. PyTest. Oh, it doesn't give me. Okay. Either way, you get the point, which is this raises a final found error, and that's how it's catching it now. And now the test passes because it's actually raising it. And the way we can actually test this is, yeah, no, okay, that's it. That's what I want to show you. And then we'll move on. We'll write detect labels function. So like I said, detect labels takes a picture and it lists out or gives you a list of objects that it detects in that picture, right? So for this, I need to use PyTest mocker as well. So PyTest, we installed PyTest mock up here, as you can see. This is inbuilt Python's unit test. When you use patch, this is the equivalent of it in PyTest, which is in order to mock a function or a class, you need to use mocker in PyTest. That's the only difference. As you remember, in unit test, you just use patch, right? So this is the only, you're just using mocker, which is not a tool to patch any function or external calls. Generally, in unit tests, you use patches to block external calls. For example, in this case, you actually don't want to call detect labels function, which means calling an actual API externally, right? You don't want to do that. You want to patch any external calls. And in this case, that's Beta3. I want to be able to patch this detect labels call, and I'm actually just testing with the return value of myself. So what I can do then is saying, hey, I want to patch recognition client, which is this guy, right? So what's recognition? Recognition is an instantiation of this class. What's the client? Right? When I say recognition, the recognition client, this is what I'm talking about, right? So I'm actually patching this such that this call doesn't get out. Like you never make that call. And yeah, once you patch it, what you can also do is you can say, okay, what call? So I'm patching detect labels call, which I'll implement here in a second. And I'm saying the return value should be, you can give it your own return value, saying you expect it to return this value, right? And this also back to the point where I said it serves as documentation. This is what I mean. As you can just simply come here, okay, this is what it returns, it looks like. And then you can be like, okay, you can write your code according to that. So in this case, what I'm doing is I'm calling the detect labels function, this guy. I'm giving it an image path, which exists. And I'm saying, it should return labels, which is a list. The labels, it should be greater than 0, which is this. This is what you expect to return, labels. And you expect these values, right? Which yourself, you're setting it here. So at this point, this should fail because you haven't implemented the test, right? So I'll just run this, make test, detect labels. Detect labels. As you can see, this failed, right? Assertion error, it says false. This is false. Right? Labels is not a list because it doesn't return anything. It's just return none. Right? So now we go and implement the actual code, and I'll show you and actually run it as well, just so we can have some fun. What we'll do now is we'll actually implement the test. Oh, right. We'll get the image bytes, which is this function that we need. Once we get those image bytes, we'll actually call recognition client, which is beta3.recognition here. And then we'll call the detect labels function, which we're patching here, and we're giving it the bytes of the image. And we expect the response to have labels, which we return from this function. So what happens now? When we test it, that passes, right? Because it's actually not making an API call, it's blocking it, and then it's returning this, right? So because, I don't know, does it work? There you go. I don't have access to an Amazon account to actually make that call. So how is this test passed? Because we've mocked the result of detect labels to be this, and we're asserting against that, right? And you see cases where, because I'm not really a big fan of this, because you're actually saying, okay, I as a developer expect the return or the response to be this, but like how? Like, am I the source of truth? I'm not the source of truth. I can make a mistake. I can be like, oh, I can just remove this confidence thing and it might not be there, and someone might look at this as a documentation, and then they might code saying there's no confidence in this dictionary, but there is, right? So I'm not a great fan of this. The other way you can write tests for this is you can patch it, right? You can patch it without giving it a return value, and you can say, now you can say recognition, something like assert called once with, yeah, because we're calling it with this image, right? There you go. So what you can say is, you can say, all right, I expect that this function was called with this thing, right? The response of get image bytes, right? Which is, this is the response of this function, which is correct. So I expect, so when I call to detect labels, I expect that to call image bytes. And that's all I care about, right? And this actually is good test because you're not giving it random values. You're not assuming things. You're actually working on facts, which is, hey, I expect it to call image bytes. And it did. It's saying assert called once with. Right? So just wanted to make that clear as well. Is it depends what you want to do. Sometimes you don't want to write test data, like you just don't want to create those data because it's like I don't know, it's like source of truth. Like, what's the source of truth? Sure, it's like you got it from a response. That response might change after 6 months as well. So there's a little bit of trade-off when you want to test it that way, when you want to write some test data and do things like this. Because this is really simple. This is really actually like this. We basically checking everything. We're saying, okay, call this, I call this, call this, I call this, done, right? You don't have any data in there. So just wanted to make that clear. So now let's have a little bit of fun, right? I think we won't do everything today because of the time. What we'll do is we'll test one more function, and then we'll actually wrap it up for today because of time, right? So, but first, what I want to do is now have a little bit of fun. I actually want to go to my our Xplorers account. Now, when I run S3ls, yeah, there you go. I mean, I'm authenticated to Xplorers account. So what I've done is I've got a bunch of pictures. As you can see, Chris Hemsworth, I've got a city, got some pictures with life is beautiful, text in there, and a plain image that's got nothing. So what I'll do is I will go here and I will actually uncomment this. I just want to run it. I just want you guys to see that it actually works. And we're just not just writing test for the sake of doing TDD, right? We just want to make sure that it works. So images. Large. So I'm checking this image here. I'm calling detect labels. Remember, this function detects any objects in the image. And then what I'm doing is I'm printing all the objects and the confidence. So the confidence is like, how confident is the AI on figuring out if this is that object that it tells me that it is. So I'm passing in this large image, and let's see what it does. I can say simply recognition.py. Right, there you go. And is that true? You guys can tell me if that's true. Right, so obviously in this picture, yeah, there's urban, yeah, cool. There's architecture, yeah, building, cool. Outdoors, yeah, nice. Basically now at the end, so after doing TDD, writing all your tests, writing all your code, then you actually go and test the actual functionality, right? So that's the whole sort of methodology of using TDD is like, at the end, you're like, okay, does it actually work now? And most of the time it should work because you've written your tests in such a way that you've captured all those edge cases. So at this point, you just enjoy the output of your code, right? So that's that. What I also wanted to show you was what we'll do is we'll just implement detect celebrities so we can test that another function as well before we wrap up. What we'll do is, actually, sometimes you also want to try capture all those retries, right? So for example, you can say things like, I'll just show you quickly. For this same detect labels function, you can say things like, oh, and where do I get this, you might ask? So I'm saying I want to patch the client the same function, but this time I have a side effect. And this is how you can catch for exception. You can say, hey, when I call this function now, raise this client error. And the client error is internal server error, which is part of our requirements, remember? So, and I'm saying when I call the detect labels function, this time it raises this client error. And the error code is going to be internal server error. That's what I'm saying, right? I don't know if it's still working on tests, but we'll see. Patch recognition client. So where is this coming from? Detect labels. Yeah. So this one, let's get that going. Yeah, so there you go. That passed. So what I'm saying is basically we're actually testing for exceptions as well. And where did I get this? You might ask. So am I making this up? No, I'm not making this up. So generally, when you're gathering requirements, what you also do is you go to your Beta3 document, right? Beta3 recognition, right? Beta3 is a package that you use to interact with Amazon, and you have all the documentation for it. So I came here in the documentation. So when I wanted to implement the detect labels function, for example, I come here into the documentation. As you can see first, though, you implement the client, which we've done. Once you have that client, You then go into, oh, okay, this is how I call the function, right? And that's how I was able to say, okay, this is an image. It needs an image. It could either be bytes or it could either be an S3 object. Cool, that's fine. And then you can see what other arguments that it takes. You can see what requirements, what arguments are required and whatnot. But the other thing that I want to show you was if you go all the way down here, what the response is like. You can see all of that here to write your code, to write your tests with. And then finally, all the way down here, you can also see exceptions, right? Generally, when you're writing a code, you always come here and you make sure that you capture, or because you have to retry. For example, internal server exception, throttling exception, provision throughput exception. These are exceptions raised by the Amazon services. And Amazon's just like, hey man, you got to retry, right? Which what I'm saying is these are exceptions that we don't have a control over. We can't make it better or we can't make it go away. These are always going to happen. And these are errors thrown by a different service. Like for us, it's a third-party service, Amazon, right? It's like, hey, Amazon's like throwing us an error. It's an error that we can retry. So what we do then is generally have automation around it to say, hey, if I see the error, I'm just going to go retry for like 5 times, for example, with an exponential backoff or whatever, which is going to go off and retry. So for things like that, you have to remember to check what exceptions and things like that as well as part of your requirements, and then writing your tests as well. Yep, so that's the other bit that I want to show you. Hopefully, those are the edge cases. And now, before we wrap up, I just want to show you the celebrities one. Right, so we'll skip the detect text one. Oh, where is it? Oh, sorry, I'm in the wrong one. Okay, yeah. Test over. Oh, what am I doing? Okay. Detect text. I'll just show you. Because I think we'll wrap up on the test side of things, because they're similar now for all this. What we'll do is I'll show you the actual code bit. So that's detect text, and there's detect celebrities. But as you can see, you know, I'm doing the same thing for all those other tests as well. I'm just making sure that the result is the same that I expect, which I'm creating myself, which I don't like because I'm creating my own data. And then detect celebrities, right? So what I'll do is I'll come here, get this guy, and we'll just play around before we wrap up. So I've also got other pictures here. Let me close actually all of this. And if I look at recognition, so what I can show you is there's images, there's Chris Hemsworth that you saw already, right? So then if I go down here, celebrities, right? So I'm passing it, I'm calling the detect celebrities function, which is here. It's calling recognize celebrities, and it's the same thing, passing in the image bytes. And then in response, I'm getting this celebrity faces key, right? And then all I'm doing is I'm printing the name, the URLs that I can go read about Chris Hemsworth, and also the confidence that, how confident is the model in predicting that this is Chris Hemsworth, right? So go ahead and run that. Python 3. All right. And what's happening here? Oh man, what's happening here? I think I have another. Yeah, okay, there you go. So as you can see, it's telling me that the celebrity is Chris Hemsworth. These are the wiki URLs that I can go read about him, and it's 99% confident that it's Chris Hemsworth, right? So it's pretty, just an example that I wanted to show you. And the other example that I wanted to show you was things like you can detect a text. Life is beautiful. JPEG. This is as you can see, it's got these texts. Life is beautiful. And what happens if I run it now? Run the function. What you'll see is, yeah, it detected these texts in this picture, which is pretty cool, right? It's not perfect, but as you can see, it's got there. Life is, beauty, and then saying that's full at the end. It thinks it's a different word, but it's not. Yeah. So these are the functions. And if I show you one last thing, I wanted to tell you that I didn't go through a test because of time, but effectively at the bottom, I'll leave this in GitHub, but you can see I'm doing the same thing. I'm patching the object, I'm giving it the response, I'm expecting it to be that, right? Same thing for, and then implementing the deck text, which is the green portion, and then same thing for celebrities, and implementing that, right? So all of that. That's it in terms of testing. What I wanted to show you is another gotcha now. This is another gotcha. Oh, what happened here? Right. What you'll see here is why do TDD, right? This is one of the issues that it helps solve, which is when you do feature-driven development, it's really easy to get into a situation like this, where you're effectively doing a lot of things inside one function. For example, I've got 3 clients here. I'm doing an S3 upload file object function here. Then I'm triggering a Lambda function. Then I'm getting the response. Then I'm actually interacting with the database. This is very messy, right? This is complex. This is very hard to test. What will a test for this look like? What is it going to look like, and how bad is it going to be? Right. So if I go all the way here, just look at the amount of lines we have to write to test this function. Like, look at this, right? This complex function that does a lot of things. Look at this test. It's hard to read. I don't know what's going on when I look at it. Just skim through it. I have to read through every single thing to figure out what's going on, and it's very hard to test, right? Because you're patching this object. You're making sure that it has this calls 3 times. You're saying, okay, I'm also calling upload file. I'm also invoking a Lambda. I'm also doing a Dynamo interaction with a database here. So doing all of these things, and this is not great. Like, this kind of code, this wouldn't happen if you did TDD, because TDD helps you break down such problems into smaller tasks. Because the way I did it, if you remember, I was like, oh, I need to upload an image, so I'll make that its own function. So I already broke it down to its own thing. Then I'm like, okay, I need to detect objects. So that's going to be its own thing. And I worked on that. Then I worked on detect text and detect celebrities. Right? So I'm working on them. You can work with them in isolated fashion. You can test them separately. There's isolation, separation. They're loosely coupled. Versus this is all tight coupling. If you know that tight coupling in code is no good. Where, if this thing breaks, for example, if this thing breaks, you never get to the database. So what happened to that data? Is it lost? You know what I mean? Like, there's so many questions. Even just looking at this code, I have so many questions. I'm like uploading this data over here. I'm like, what happens if that fails? Right? And what does it have to do with this function? Like, they're not related. What does it have to do with database? It's not related. Helps you think about this up front. You shouldn't get into this situation at all when you do TDD. Because now let's look at the broken down version of this, right? Because if I was doing TDD and if I was coming up with requirements up front, I'd be looking at uploading file separately. I'd be looking at invoking the function separately. I'd be looking at storing the results in database separately and calling them like this, right? Where now I've effectively isolated complexity into all of these other functions, and all I'm doing is then calling all these functions down here. And now let's look at how do you test this? How easy is it then to test the simple functions? Look at this, right? I'm testing the client separately. I'm testing upload separately. I'm testing Lambda separately. This is separate. Everything's separate, right? It's clean. It's readable. Everyone will be happy to jump in because they're like, oh, I understand this. It's not a lot harder. I can just go like 3 lines of code, 4 lines of code. I can read it. I can be like, I'm interested. Versus this, I'm like, man, why is this so hard? What's happening here? I have so many questions, right? So this is another thing where, it might be motivating. It might help you think about programs, making your code better, isolating things, less coupling, all of those things. Okay, I think that's pretty much it. I took way longer than I should have, but I got. I'm really sorry, but that's pretty much it. Do you guys have any questions?
I think this was really cool class.
Yeah.
I learned a lot. I mean, I have seen code like this in our repo as well internally, but I didn't have much understanding of it. But now I get it because we write like SSM dots, which follows this the same testing pattern. So we write test cases for steps in your system document,
Yeah,
and now it follows it like everything. I mean, in lines.
nice. That's great, bro. Thanks for the feedback.
एकदम मलाई नि एकदम हेर्दा चाहिँ कुल लाग्यो मोस्टली चाहिँ मैले बुझिनँ बट जुन त्यो रन गर्दाखेरि त्यो लाइक सेलिब्रिटी